Hello everyone. We'll try to solve the first problem here in the handout. In the first handout, you are given those three formulas, and you're asked to develop three more formulas, or actually five more formulas, based upon those three formulas. The first equation we are going to try to develop is an equation for the final velocity, v final, in terms of v initial, acceleration, and the time. So v final has to be on the left hand side of the equation, something like that, v final as a function of v initial, acceleration, and time. That's what we need to find. If we look at the three formulas we have, all of them contain v final, or the average velocity here is v final minus v initial over 2. So all of them contain v final. So we need to look for equation that has v initial, acceleration, and time in addition to v final. If we look for the equation that contains those, we'll find it's the third equation. The third equation has the acceleration in it, which we have it here. It has, of course, v final, so there is v final. And it has v initial in it. In addition, it has the time, and here we have the time. So all what we need is to rearrange this equation to solve for v final. We need to leave v final on one side, while the other three terms need to go to the other side. So to do that, we'll start by multiplying the two sides of the equation by t. This will yield at equal to v final minus v initial, because the time will cancel out here. So if we add the initial velocity to both sides of the equation, this will yield v initial plus at equal to v final, and this will be the final equation. V final is equal to v initial plus at. So now we have an equation that has v final on the left hand side, while it has the three terms here, those three terms on the right hand side. Now let's try with number 2 here. In this part we need to find the distance, and it has to be in terms of v initial, acceleration, and time. So we need to look for the equation or the equations that contain distance as well as v initial, acceleration, and time. If we look here on the top, the only equation actually that could contain all of those, the first equation. The first equation has the average velocity, and remember the average velocity is what? The average velocity is v final plus v initial over 2. So it has v final and it has v initial, as well as distance and time, but it does not have acceleration. So what can we do? So let's first write the equation here. So that the average velocity is v final plus v initial over 2. That's the left hand side of the equation. This is equal to distance over time. Now what we can do here, we can replace v final with the formula that we find in number 1. So we'll replace v final here by this formula. So let's go ahead and erase v final. So I'm erasing v final here, and replace v final by we have v initial plus a times the time. Initial plus v initial will give you 2 v initial plus at plus the acceleration times the time. The whole thing here is divided by 2 equal to the distance over time. We can write it here as 2 vi over 2 plus at over 2 equal to d over t. Okay, so 2 will cancel out with 2 here, so we'll have vi equal, so this will be vi plus a times t over 2, this is basically 1/2 at, is equal d over t. Now to get rid of the t, so in order to get rid of the t here in the denominator, we can multiply both sides of the equation by t. On the left hand side, it will be vit plus 1/2 a times t, which is t squared. This will be equal to d. And this will be the last equation. Okay, so in addition to the three equations we started with, now we have a new equation. Here we are asked to derive three more equations. It has to do with the acceleration, so we need to find the equation for the acceleration. It has to be as a function of the initial velocity, distance, and time. So again, we need to look for the equation that has acceleration, initial velocity, distance, and time. And we can see actually that the last equation we derived has the acceleration that we need to find, and also it has the initial velocity, distance, and time. So we can rearrange this equation here to solve for the acceleration. Alright, so now to solve for the acceleration, we have to move the initial velocity and the time to the other side here. So it will become d minus v initial, the acceleration, times t squared. And now let's go ahead and multiply both sides of the equation by 2 so that we can get rid of the 1/2 here. Okay, so we have on the left hand side 2 times the distance minus 2 times v initial times the time equal to the acceleration times t squared. Now we need the acceleration on one side alone. To get rid of the t squared, we have to divide the equation by t squared over t squared minus 2vi times t over t squared is equal to the acceleration. Now we'll simplify, and this will be the acceleration in terms of distance, time, and initial velocity. Okay, in question number 4, we are asked to solve for the time when you know the distance, acceleration, assuming v initial is 0. So we need to look for an equation that has the time, distance, acceleration, and initial velocity. We can see here there is no one equation that contains those 4 variables. But we have here equation number 1 has the distance, time, and of course the final and the initial velocity. So if you started with the left hand side here of equation number 1, and we replace v final plus v initial over 2, we replace the average velocity with this formula. This is equal to the right hand side, which is d over t. And then let's go ahead and replace v final by the formula we find for v final, which is v initial plus at. This is still plus v initial. So this is v final here over 2. This is equal d over t. And now we'll do the simplification here. 2vi plus at, the whole thing over 2 equal to d divided by t. Now remember here we are trying to solve for t. So we're going to multiply both sides of the equation plus at squared over 2. This is equal to the distance. Now if you multiply both sides by 2, then we'll have at squared. Let me go ahead and write the t squared here first. Plus 2 vit equal to 2 times the distance. Let's accumulate all the terms here on one side, so the other side will be 0. So we'll have here the acceleration times t squared. 2vi here is 0, since we are told in the equation that. So we have at squared minus 2d, or equal to 2d. This will give us t squared equal to what? Equal to d over a, meaning t is what? T is square root of 2 times d over the acceleration. Now does that match the units? In terms of unit, remember the unit of the time is second. So let's look at the unit of the square root of 2d divided by the acceleration. 2 does not have unit, d is meter. Acceleration is meter per second square, and all that is under the square root. So here we have meter will cancel out with meter, so we have the square root of 1 over second square. That's the square root of second square, and that's second, so that's exactly the unit of the time. That's only in the case of the initial velocity equal to 0. Okay, question number 5 asks us to formula for v final. If we are given the initial velocity, the acceleration, and the distance. If we look at our equations here, number 1 does not have acceleration. Equation number 2 has the acceleration but does not have distance. Equation number 3 is the same as equation number 2, only different arrangement. Equation number 4 has distance, initial velocity, time, but it does not have the final velocity. We can rearrange equation number 2 to find the time in terms of acceleration, final velocity, and the initial velocity, and then plug the formula of time into equation number 1. If we rearrange equation number 2, it will be time equal to v final minus v initial over the acceleration. Okay, so let's hold on this one. Now let's go to equation number 1. Equation number 1 tells us that the average velocity, which is v final plus v initial over 2, is equal distance over time. Now if you go ahead and replace the time by what we found here, let's separate here everything. And instead of the time, we replace it by v final minus v initial over the acceleration. Okay, let's go ahead and arrange the equation. Let's multiply both sides of the equation by the term here in the denominator, that's v initial, and on the right hand side will be left by the distance. Yeah, I'm just reminding you with math here, when you have minus y times x plus y, this is basically equal to x squared minus y squared. This is from math. And this should be equal to distance. Let me erase this part here on the right hand side so that we can complete the equation. Alright, so I'm completing. Now remember, we need to find V final, so we'll go ahead and multiply 2a by both sides of the equation, so that will leave us with V final square minus V initial square is equal to 2dA or 2ad. And then we solve for V final square, so V final square equal V initial square plus 2ad.